How are you, everybody who is watching this video? I would like to take this opportunity to welcome you into a very interesting online institution that's called Tanzania Online Institution, Institute of Technology, where that we are trying our level best to teach students in different levels. Actual students who are beginner engineers and professional engineers, but also we are teaching professional engineers and even those who are intermediate. My name is Olenjolai. It's the first time to meet me. I would like to take this opportunity to welcome you into departments of electronics engineering. And we have a number of modules that we are teaching our students in first year, second year, third year, and fourth year. But today we are going to have a critical discussion about power electronics as a very important branch of electronics engineering. Myself, I thank God by His own grace, I am electronics and telecommunication engineer formally. I'm also a local teacher who is teaching at Dar es Salaam Institute of Technology. But by God's grace, I'm also a national teacher and engineer who is trying to solve the problems of learning electronics engineering and telecommunication engineering in my own country. So it doesn't mean that we are focused on teaching the Tanzanians only. No. First of all the stuff that we are going to discuss that have been innovated from other countries. So regardless of which country you are, you can take advantage of learning with us. And this is the precautions, or this is the safety precautions of Olenjolai. Olenjolai does not know everything about power electronics. I'm always learning because I love so much power electronics and I love so much electronics engineering. But the small portions of the knowledge that I have in power electronics and electronics engineering, I have a responsibility to teach others about what I know. So don't expect that I know everything. No, nobody who knows everything. I just know small portions of it. The important things which I want to address to you, these are the serious classes. I would like to have students who have fresh mind, who will be asking questions, and who are ready to learn and be transformed from the ignorance phase into understanding phase, and later into the applications of what we are going to teach you. In this module, we have theoretical concept, and also we have simulation, and later on we have the experiments or the hardware implementations of this system that we are going to learn. I have some physical students who are pursuing bachelor degree in telecommunication and electronics engineering at the Dar es Salaam Institute of Technology that have joined me in this class. But I have hundreds and thousands of the students who are not physically in this class. So all of you, I believe that I have prepared something important to feed your mind today. So be serious, have your exercise book, have your pencil, have your rubber, have your sharpener, have your ruler in order to learn, because we are going to have some drawings in the next part. Then I want to talk a little bit about the second chapter. We are going to start the second chapter that's called the Power Electronics Devices. And this is just lecture 1, Introductions of Power Electronics Devices. However, that we discussed this phenomena as one of the terminology in a first topic, but in this topic we are going to get into too much details concerning about what we've introduced to you in Introductions to Power Electronics. So let me appreciate some physical students and let us start the class. One thing which I want to ask you, prepare a number of questions to ask me so that you can have a broad knowledge about electronics. I'm happy, I'll be trying my level best to entertain you, because electronics engineering is a beautiful academics and the industry for the present and future life. How are you, electronics and telecommunication engineering students? Yeah. Are you ready for today's lecture? Yes. Yeah, so what the names are, okay, read the name of the module. What module are we going to learn today? Good. Which chapter are we? Which chapter? Chapter 2. What is its name? Power electronics devices. Say again. Power electronics devices. We are in lecture 1. What is lecture? What are the names of lecture 1? Introduction of power electronics devices. So in this topic, we are going to discuss about power electronics devices. Are you ready for the lecture 1? Yes. Well, so because we are starting a new topic, there's no quick review, because this is the new topic. We'll have quick review in lecture 2, lecture 3, lecture 4, etc., etc. So straightforwardly, let us define or redefine again the terminology called the power electronics devices, or have an introduction concept about this topic. So straightforwardly, this is question number 1. So question number 1 is, what is power electronics devices? We have defined this terminology in the previous topic, but let us remind ourselves before we go in detail or in depth of it. Students, who can try to define power electronics devices? Who can try to define power electronics device? Quickly, please, hurry up. Who can try to define? We defined it, or I gave you a number of definitions. Don't read right now. You should keep them in your brain. I gave you a number of definitions of of power electronics devices. So who can define power electronics devices for us? Physical student, you don't remember anything?
These are devices which are used in power electronic engineering, which can convert and control the electrical power.
Use this mic. So tell us your name and give us definition of power. Try to define the terminology power electronics device. Quickly.
My name is Olenjolain Steven, and power electronic devices, these are devices which uses the solid state electronics, which can convert and control the electrical energy.
Which can convert and control electric energy. Good. Try. Clap your hand for him. The other students who can try to define? Who can try to define the meaning or the word power electronics devices? Will you try? You may read if you have written somewhere. Would you like to try? No. Okay. So, thank you for trying. So, power electronics devices can be defined in different styles. So, because I told you in previous topic, but maybe you did not understand. Because you just wrote, and then you did not transfer what you have written in your Excel book into your mind. Power electronics devices. So what are the power electronics devices? So let us define this in plural. So power electronics devices are semiconductor. These are semiconductor. So these are semiconductor based component. These are semiconductor based components. These are semiconductor based components that are used to control, are used to control, to convey, so are used to control, to convey to what? And the condition electric power. And condition electric power. Condition electric power in various applications. In various sort of applications. So this is one of the definition. So writing, power electronics devices are the semiconductor-based components. Say semiconductor-based components. Used to control or convey or condition what? Electric power in various sort of applications. Those are the keywords that you have to remember. So you should not just claim the definition. You just have to remember the keyword semiconductor-based components, then used to control, just you have to remember control, convey, and condition electric power in various applications. It means there are some applications where we have to control electric power. There are some applications where we have to convey electric power. There are some applications where we have to condition electric power. Are we together? Are we together, class? So that is one of the definitions. So because I want you to understand, then I found a second definition of power electronics. Maybe you are not confident, or you are not happy with the first definition. Power electronics devices. So power electronics devices are the devices or are the electronics, okay, are the electronics devices, are the electronics devices. So these are the electronics devices, are the electronics devices used to to manage. So this might also give manage or control or convey and what? And the conveyed electric power into various forms. Example, power electronics devices can convey DC to AC. Power electronics devices can convey DC to DC. And also power electronics devices can convey AC to DC. And power electronics devices also can convey AC to AC. So whenever you are defining a terminology in electronics engineering, you have always to support with examples or drawings. Okay? Okay? Yes. So stop writing. Let us discuss the second definition. Power electronics devices are the electronics devices. Say, are the electronics devices. We are using them to manage electric power. We are using them, or are the electronics devices used to manage electric power into in various applications. Also, they are used to control electric power, and they are also used to convey electric power into various forms. Say various forms. So this is one form into another form. 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 So you can notice from these two definitions, actually each definition add the value to the other definition. For instance, this first definition adds some value into the second definition, and the second definition adds some values into the first definition. Hello? What did I say? Hello? What did I say? What did I say? Hello? Before I say the hello. Eh? He wasn't in class. So I say, let me repeat for the benefit of my students there. The first definition adds some value into the second definition. And the second definition adds some value into the third definition. What do I mean? For instance, in first definition, okay, so you say these are semiconductor basic components, use it to control, use it to convey, use it to condition electric power in various applications. So the first definition mentioned various applications, while in the second definition, there is no terminology called the various application. Then the second definition adds some value into the first definition. Why? Because you can find that in the first definition, we don't have management of electric power. But in second definition, we have management of electric power. It means semiconductor devices can also manage electric power. And then in the second definition, we have also that this management or control or conversions of electric power is being done into various forms. So we have various forms. While in the first definition, we did not talk anything about various forms. But in the first definition, we did not mention the examples of such kind of the control or such kind of the conversion. But in the second definition, we have some examples of conversion. Because this is conversion of electric energy. Are we together? Yes. Okay, well, so the third definition. We say that power electronics devices are the solid state devices that are used to control and they convey electric power. So they are used to, these are the solid state devices which are used to control and they convey electric power. Electric power from one form into another form. So you may note that, stop writing. So the third definition, power electronics devices are the solid state devices. Say solid state devices. Solid state is the AKA of semiconductor. So these are the solid state devices that are used to control and convey electric power from one form into another, form. So in the third definition, you may notice that one of the keywords that we have seen in the first definition, second definition has been left. And what that keywords? Conditioning. Two keywords have been left: conditioning and managing of electric power. So I've taken this definition from different sources. I want to expose you that when you go maybe online, where actually that you can search definitions of power electronics devices from different sources, you have to expect it to find different definitions. Are we together? Yes. Are we together? Yes. So actually I recommend the first definition and second definition to remain in your mind. Because, so it means, for instance, myself, if I could be you, I can compose another fourth definition by actual combining all these three definitions and come up with one definition. If I could be you. But because I'm not you, we don't know if we will combine them. Will you combine them? When? Will you combine the three definitions and come up with one? No. You don't know. I'm talking to you. Oh, you are not sure? You are always not sure. Okay, so now, because I taught you this definition in the first topic, but you did not click up or you did not keep in your mind, but today, I have an intention that you should remember the definitions of power electronics devices, whether you are close to your exercise book or you are far from your exercise book. So we are going to reinforce your understanding right now by reading all the three definitions of power electronics devices, then we'll be moving into another concept. So 1, 2, 3, go.
Power electronics devices are semiconductor basic components that are used to control, convert, and condition electric power in various applications. All power electronics devices are electronic devices used to manage, control, and convert electric power into various forms.
You are now, you have actually you have attenuated your voice. Read the said one. 1, 2, 3, go.
Electronics devices are the solid-state devices that are used to control and convert electric power from one form into another form.
So did you understand? Okay, if you have a question about definition of power electronics devices, ask it. So he said that power electronics devices are crucial in real life application, such as in real life application, daily life application, such as power supply, such as motor drivers, such as motor drivers, and the renewable energy. We are using also this in renewable energy. Renewable energy system. Renewable energy system. The renewable energy system. And more than that and more. You have a question, you are welcome. Can you speak loudly? Let me give you a microphone. Should not worry. Just introduce yourself, then ask your questions.
My question is, what is the difference?
Introduce yourself, please.
Okay. My name is Astrida Frederick.
So what's your question?
My question is, what is the difference between managing and controlling power?
Managing and controlling power.
Yes.
Okay, so you said your name is Astrid? Oh?
Astrida William.
Huh? Astrida. So do you hear Astrida's question? Hello, madam. Are you there? Madam was not there. Do you hear Astrida's questions? What the difference between controlling and the managing or management? Thank you for your question. Tell us, who can give us the difference between managing or management of electric energy and the controlling of electric energy? Who can tell us? What the difference? Or are they similar? Tell us. Who can try? Please, students, in case you want to learn something, you should always be capable and be conversant to create questions. Because through questions, you can learn different concepts. Gideon, tell us. Is there any difference between managing electric power and controlling electric power? Tell us what the difference. Is there a difference or there's no difference? There's a difference. Can you speak loudly, please?
There's a difference.
Can you tell us? So you can tell us one difference, isn't it? Okay. So Gideon is going to tell us one difference. Tell us.
The first difference is that management, it's like handling.
Can you speak loudly as how you used to provide the announcement? First of all, introduce yourself. And then speak loudly as how you are providing announcement to the class.
Okay, my name is Gideon.
Do you hear Gideon's voice?
And I'm going to tell the difference between management and controlling. When you talk about managing, it's like to handle.
So Gideon is saying when you talk about managing something, is about what?
Handling it.
And when you talk about controlling,
it's all about controlling. It's all about to put it under certain condition.
To put it under certain condition.
Yes.
Okay, that's the first difference. The second one?
Managing it.
Okay, thank you for trying. Clap your hand for him. Okay. So, managing electric energy or management of electric energy. It means that, for instance, we have converted the AC into DC, for instance. Then, within that system, all that semiconductor devices has always to manage or to give a reliability of that system to provide pure DC. That's what the meaning of management. It means you are managing something which is actual required. Okay? When you talk about controlling, it means that actual something must be controlling another thing. Are we together? So management is just maintaining. For instance, yourself, I believe that we as a human being, we use always to manage amount of the food that you are taking in, isn't it? And then maybe you find that our enzymes will actually controlling the digestive process within our bodies. Are we together? So you can find that when actually you don't go in depth, you may find that managing and controlling are the similar terminologies, or managing and the conditioning, but actually they are different terminologies. So it means that managing is keeping something constant, right? Right? Controlling is actual that you may keep something constant or changing according to the standards which have been set. Are we together? Are we together? Thank you, Astrida, for your question. Then let us now discuss this sentence. Power electronics devices are crucial in real-life application, such as power supplies, motor drives, and the renewable energy system, and more. So why are we learning power electronics devices? There are so many reasons, but that one is one of the reasons. We are learning power electronics devices because these are the crucial devices in our daily real life. We've been given some examples. Where do we use these power electronics devices? In power supply. Say power supply. So power supply, so in talk about power supply, simply we have two types of power supply, three types of power supply. DC power supply, we have linear power supply, and switched mode power supply. So AC to DC, this is linear power supply. And then DC to AC, this is, okay, not switched mode actually, it's not switched mode, but also it's a kind of the switched mode because this is the inverter. And the inverter is used in switched mode power supply. Then we have motor drivers. Say motor drivers. Say motor drivers. Say motor drivers. So motor drivers, these are the drivers which driving motors. Driving what? Or controlling what? The operations of what? Of motors. So listen, let me just tell you how this happens. I want to expose you into the field of electronics. For instance, in most of electronics application, we may have a block here of the sensing, let's say sensing unit. And also here we can have a block of microcontroller. So microcontroller, for instance, microcontroller. So you just want a sensor, for instance, let's say IR sensor, to detect the presence of the person at the entrance door. Then this signal will be sent to the microcontroller, and microcontroller has to send the signal to the motors to open the door. Listen, one of the applications, real-life applications of electronics or power electronics devices, we use them in case of the lift system or elevators. Do you know elevators? Eh? Do you know elevators? Yes, so elevators and the escalators. So you say escalators are the one that actual that you find that there is a chain that will be rotating. When you talk about electric lift, we mean that those are the actual that are the cars. So you use actual that when the lift arrives, the door gets open. Once you enter, then there's the two sensors, or there's the number of sensors within the entrance door. One is infrared transmitter, the other one is infrared receiver. So between one side of the door, of the lift door or elevator door, and the other side, the signal or the light will be transmitted from the transmitter, IR transmitter, to other sides that are IR receiver, which is photodiode. So if this signal will be blocked, then the information will be sent to the microcontroller or to the PLC, and the actual will be sent the information that there is a person standing at the entrance door. Don't close the door and don't move the car. Okay? If then there's actual that the light from transmitter one side of the door to the other side of the door, actual that means that it's not blocked, then the information will be sent to the brain or to the control system that now there's nobody at the entrance door, close the door and move the car to the destination floor. Okay? So actually the door, the elevator's doors are get opened by the AC motors. Say AC motors. So there's a motor that actually opening it. So those motors consume consume large amount of currents, and also they operate in terms of AC. How this microcontroller, which is actual low current devices, control it? Well, so once the signal taken from the microcontroller will be sent to the another block that's called the motor driver. Say motor driver. So motor driver. And then the outputs of the motor driver will be actually sent to the motor. Are we together? So these motor drivers are made by power electronics devices. Why do we need these motor drivers? Well, the question is good. For instance, the output currents of the output pins of the microcontroller in each port is 40 milliampere. Okay? While most motors needs almost greater than 1 ampere. So you have the signal 4 milliampere, then you want to drive a motor that consumes more than 1 ampere. What should be happen? It means we should need a current amplifier. That amplifying a current of 40 milliampere into a current of 1 ampere. Or intercurrents of 2 ampere, or intercurrents of 5 ampere. So these motor drivers are the one that we call them current amplifiers. Say current amplifiers. Say current amplifiers. But another crucial applications of power electronics devices, we are using them in renewable energy system. Say renewable energy system. Say renewable energy system. What the means of renewable energy system? This is the system where actually that we can renew a particular energy which has been consumed. Are we together? So actually reusing of the energy. So for instance, let's say that for instance, it means that we say that you can make something. So let's say that you have a diesel. So you have a diesel. I'm trying to think about the air. Okay, so actually it means that for instance you have solar energy. If solar energy is renewable, it means you use solar energy and then you can renew what has been used. So we are using also power electronics devices in case of those systems. Are we together? Are we together? Are we together? So another important feature of these power electronics devices is this one. Power electronics devices are designed to handle. These are designed to handle what? High voltage, are designed to handle high voltage and a high current. High voltage and high what? Current. So this is another important feature. Not all semiconductor devices are designed to handle. Remember that most of semiconductor devices are designed to handle low voltage, low power, and low current. But another additional feature of semiconductor devices, these are designed to handle what? These are designed to handle what? So this is point to note, not number 1. And this is not number 2. We say that most semiconductor, we means electronics devices, semiconductor devices are designed, this is a very important feature, designed to handle. These are designed to handle low current, low voltage, for instance 1.5 volt, and a low power. Because if you have low current, remember that we have defined these are designed to handle. We defined and we've established the mathematical definitions of power. So most semiconductor devices or most electronics devices are designed to handle low current, low voltage, low power. Okay? Why didn't he mention, sometimes we may not even mention low power, because remember that, my student, we have learned that electric power, this is calculated by taking current times what? Voltage. So for this case, if you have low current, in case of power electronics devices, we may have a power electronics devices that handle high voltage, low current. Power might be high because if voltage is high, it can increase power. Hello. Listen. We say that with this mathematical equation, it means power is directly proportional to the electric current, but also power is directly proportional to the electric voltage. It's directly proportional to electric to the voltage. So listen, power, we can have high power with 3 possibilities, or 3 combinations, or with 3 possibilities. I say separating, look on the blackboard. The first possibility, we may have high current, low voltage. When we multiply, we get high power. Okay? The second possibility, we may have low current, high voltage. When we multiply them, we get high power. The third possibility, we may have high current, high voltage. We multiply them, so we get high power. So even in this sentence, we did not mention about power. Why? Because it's already there. High voltage, high currents, resulting high what? Electric power. Class, are we together? Yes. Wow. So that's what you have to bear in your mind. But other semiconductor devices, or most semiconductor devices, are designed to handle low current, low voltage, low power. Except what? Power electronics devices. Are we together? Are we together, class? Yes. Yeah. So if you have a question about what we've discussed, you may ask it. Ask questions as well as you can. Well, so after that, is there any question? No. Okay, after that discussion, then we need to know about these power electronics devices. What are they? You have a question? Ask.
They are solid state devices. At first,
introduce yourself. We don't know you.
Okay, I'm by name of Gideon Evans, and my question is: at first, when we were defining power electronic devices, you said are the solid state devices, which means, in the other words, they are semiconductor component devices, right? But for what you've written there, it's like there is a difference between power electronic devices and the semiconductor devices, because power electronic devices, they are the one that can handle high voltage, high current, and stuff like that. And semiconductor devices, they are the one that handles low current and low voltage. So I'm somehow confused, like.
Well, thank you very much for your question. Clap your hands for him. Okay, so did you understand his question? His question is actually talking about semiconductor. Listen. His questions, he said that he has been confused with that. Some of the semiconductor handle high voltage and high current. And some of them, or at the same time he heard that, also they handle low voltage, low power, low current. That's your question, isn't it? Eh? So this is the response. This is semiconductor, let's say semiconductor devices. Say semiconductor devices. We have so many types of semiconductor devices. Some of these semiconductor devices, we call them power electronics devices. Or simply in other language, we call them high power semiconductor. High power semi. But also we have so many semiconductor devices which are low power semiconductor devices. So actually, when you talk about high power semiconductor devices and low power semiconductor devices, this is actually categorization of semiconductor devices based on the amount of energy handled. Are we together? Yes. So when you talk about the power electronics devices, okay, you may find it's the same device. For instance, listen, you may find it's the same device. For instance, we have MOSFET. MOSFET is a power electronics device, but also it's a low power semiconductor. So some of the semiconductor devices can be used for the power, for the high power semiconductor, or can be used, it means that it depends, you have to change some parameter. For instance, when we use MOSFET in low power semiconductor, then there are some MOSFET transistors which have been made to handle low power. So it means the manufacturer defined the thresholds, it means defined the limits. Okay? Also there are very high power MOSFET transistors which have been designed to handle high power system or high power energy. So you may have a power electronics device which is not low power, it means high power electronic semiconductor. You may have a high power semiconductor which is not low power semiconductor. You may have a low power semiconductor which is also a high power semiconductor, and may have a same semiconductor device which can handle high power and low. It depends on your discussion. Hello, what are you thinking? Are you thinking about Mendokasi? Class, are we together? Well, so it's a great discussion. We are just introducing you. Get connected. You'll understand how to differentiate power electronics devices from other devices or low power devices. But in case you are learning with reasoning, if you're just learning to write the notes, you'll get confused day after day. Are we together? Is it clear? Is it clear? Yes. Then another important concept you should learn in introduction of power electronics devices are what? Examples. Examples of what? Power electronics devices. And after mentioning those examples, then we are going to discuss about what? We are going to discuss about them. So you have examples of power electronics devices. Say examples of power electronics devices. Say again loud, examples of power electronics devices.
Examples of power electronics devices.
So we have so many power electronics devices, but the following are some of those power electronics devices. The first one, we start always from there. Whenever we mention we are learning particular knowledge, we have to start from fundamental, then we get into advanced. Okay? The fundamental semiconductor device that's simple to teach students and understand is called what? Diode. Say diodes. So some of the diodes are used as power electronics devices. And some of them are used to handle low power devices. Right? You have to be transformed from cramming electronics and into the zones of understanding. Because you've been cramming a lot. You've been cramming that, how to calculate current gain, collector current, base current, how to calculate voltage across collector emitter, but you haven't taken your time to understand what's going on within. You've been cramming that transistor can be used as a switch. Then, okay, if you give you a transistor, can you make a switch? You know, Then the second one, which is a little bit advanced, because in diodes we have two categories of diodes. We have general purpose diodes and also we have special purpose diodes. Okay? So in special purpose diodes, we also have one type of the diodes which is used as semiconductor, which is called the varactor. Say varactor. Say varactor. So varactor, or we can call it a varicap. Varactor or what? So varactor or varicap diode. Then the third example of power electronics is called the power bipolar junction transistor. Say power bipolar junction transistor. Then another semiconductor device or another power electronics device is called the MOSFETs. Say MOSFETs. So this is abbreviations of metal oxide semiconductor field effect transistor. Then number 5 is called the insulated gate bipolar junction transistor. Say insulated gate. So insulated gate bipolar transistor. In short, this one we call it IGBT. Say IGBT. Say IGBT. The 6th example of semiconductor devices are what? Thyristors. Say thyristors. Say thyristors. The 7th example of semiconductor device is called the silicon. Silicon controlled switch. Silicon controlled switch. Say silicon controlled switch. Say silicon controlled switch. No. This is called the silicon controlled rectifier. Say silicon controlled rectifier. Say silicon controlled rectifiers. Okay, that's number 7. Number 8, for example, 8 is called the solid state relay. Solid state relays. Say solid state relays. Say solid state relays. So SSLT, SSR. Solid state relays. Then number 9 is called the gate what? So it's called the gate turn off thyristors. Gate turn off thyristors. Gate turn off thyristors. GTOs. Gate turn off thyristors. Then number 10 is called the power capacitors and the power inductors. power capacitors, and power inductors. So these are the 10 examples. So please add this one. 10 examples. We have more than 10 examples, but I've just preferred to find 10 examples for my dear students, 10 examples of power electronics devices. So 10 examples of power electronics devices. Okay, so because I want you to write these 10 examples in your mind, because we'll be discussing about them in brief, but once you understand how to use them, or once you understand them, especially in the context of power electronics devices, it will be simple for you to design or even to analyze the power electronic circuits, because in power electronic circuits, we are using these power electronics devices. Are we together? Are we together? Are we together? Yes. Are you ready to write in your subconscious mind, in your permanent memory, about 10 examples of power electronics devices? Are you ready? Yes. Ask your neighbor, are you ready? Yes. So let us write. 1, 2, so pronounce or mention means that write, pronounce this terminology. So say diodes. Diodes. Again, say varactor or varicap diodes. Varactor or varicap diodes. Again, say power bipolar junction transistors. I can say MOSFET transistors. Or say metal oxide semiconductor field effect transistor. Hello, mister? What's going on? Then say insulated gate bipolar transistor or IGBT. Remember that it's not bipolar junction. There's no word junction here. I can say insulated gate bipolar transistor or IGBT. Then the other ones is called the thyristors. Say thyristors. Say thyristors. Say thyristors. Another example is called the silicon control the rectifiers or SCR. Some of the students are not pronounced. Let us repeat. Say it and pronounce it and write in your mind, because this is what you have paid for. You have paid the tuition fee of more than 1 million in your first year, and these are the contents. These are the fruits from your tuition fee. Say silicon control the rectifiers or SCR. Silicon control the rectifier or SCR. Then another example, example number 8 is called the solid state relays or SSRs. Solid state relays or SSR. Then the ninth example is called the gate turn-off thyristors or GTOs. Then the last example, which is new for you because I haven't mentioned it in chapter 1, is called the power capacitors and the power inductors. Power capacitors and power inductors. Do you see your neighbor? What is you doing? What is he or she doing? I can say power capacitors and power inductors. So these are the new vocabulary for you. You know capacitor, you know inductor. But you haven't heard about power capacitors and power inductors. If I could be you, I could go and make a follow-up. What are those power capacitors and power inductors? You learned inductors in electromagnetism. You learned capacitors in electrostatic, in advanced electronic science. But maybe you haven't think about power inductors, because these are a little bit different from the less powered capacitors and less powered inductors. Are we together? Are we together? So in this chapter called the power electronics devices, we are going to discuss in brief each of these 10 examples of power electronics. And that discussion is very important for the future topics. And in our discussion, we'll actually discuss how or where do we apply this device in power electronics industry. So when I ask you to reinforce to understand them in your mind, or to understand these 10 examples, is because this is the foundations of our future discussion. So maybe you just know diodes from what advanced electronic science. Okay, we discussed a little bit about diodes, but maybe you haven't dig in how we are using diodes in power electronics. Okay? 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 Hopefully you have an idea about power. You just have an idea of bipolar junction transistor. You don't have an idea of power, bipolar junction transistor. You don't know them. Maybe you have discussed in practical electronics, but yes, you discuss it as just a multi-stage system, but you don't understand why this transistor has been used or why the resistance of this value has been used. You don't know the design criteria behind. You just have a schematic circuit. So once you have a schematic circuit, somebody designed it for you. And the main roles of engineer is to design. So you could not say that, I know power bipolar junction transistor. Okay, we'll see. Because one day we'll just give you some conditions and we ask you to design from the scratch. You design everything, just see from VCC to the transistor that you are going to use. Either it is single stage or multi-stage. Are we together? But in Tanzania, we are just receiving schematic circuits. And then we find that they are very complicated. We don't think why resistor has been used in 1 kilo or why. You have to ask it questions. Question everything that you are learning. That's how knowledge comes. Otherwise, you'll be just receiving and say yes, yes, yes. Even if later on, do you expect it to fail the exam? Yes, because for you everything is yes. And then MOSFET, I know you don't have idea. Maybe you heard at DIT. Then insulated gate bipolar transistor, I know this one you don't know. When it comes to resistors, maybe you read in some resources. SSCR, it's not discussed in advanced electronic science. Solid state relays, well, this is the first time. Gate turn off resistor, first time. Power capacitors, first time. Power inductors, first time. So if I could be you, I could say that I will never miss any lecture of power electronics devices because I'm going to learn new things about the semiconductor device. Are we together? Yes. Are we together? Yes. So the next short discussion is actual that we say that so he said that some of these 10 power electronics devices are used to convey electric energy from one form to another form. So listen, my dear student, listen. We say that power electronics devices can control, right? Power electronics devices can convey. Power electronics devices can condition. Power electronics devices can manage. Okay? Okay? So not all of these 10 examples are used to convey electric energy, but some of them. Not all of those 10 examples are used to control electric power, but some of them are used to control electric power. Not all of those 10 examples of power electronics are used to condition electric power, but some of them are used for the conditioning purpose. Okay? And not all the 10 examples of power electronics devices are used to manage electric power, but some of them. So that's why I have written that sentence. Some of these 10 power electronics devices are used to convey electric energy from one form to another form. Why are you laughing? So they are used to convey electric energy from one form to another form. And then, so if that's the case, it means that in power electronics, we have 4 conversion, or we have 4, we say that we have 4 conversion process, which we have discussed in previous topic. So it means that in power electronics, so in power electronics, there are 4 electric power, there are 4 electric power conversion. There are 4 electric power T. There are 4 electric power T. 4 electric power conversion. And let us mention them. The first one is called what? Conversion of what? Conversion of alternating current, in short we call it AC, into DC. And DC is the abbreviation of direct current. Say conversion of alternating current into direct current. Because sometimes it can become limited with what the long terms of AC or DC. You just talk DC. And what is DC? DC is DC. DC means direct current. AC means alternating current. So conversion of AC into what? Into DC. This process in power electronics, we call it rectification. Say rectification. Say rectification. Say rectification. Yourself say rectification. Are you sure? Then the second electric power conversion is called the conversion of what? Of direct current power into alternating current power. And this process, we call it inversion. Say inversion. Say inversion. Say inversion. We talk about inverters. Then they said the example of what? They said the example of electric power conversion is called the direct current to direct current. So conversion of, so this one called it conversion. Class A, conversion of AC into DC. So conversion of DC into DC. So for this one, we say that it implies what? It implies changing. It implies changing the voltage of electric signal. And this process, we call it in electronics, we can have 2 processes here. Voltage up, conversion, or voltage step up. Voltage step up, or voltage step down. Voltage step up or voltage step down. That's the name. However, that you can call it, what the name of this process? How do you call it? The other name? Pardon? Voltage regulation. Say voltage regulation. Say voltage regulation. So the process itself is called the voltage regulation. It's not the current regulation. In electronics and electrical, you have voltage regulation, power regulation, and current regulation. So that process is called voltage regulation. Say voltage regulation. So in power electronics, we may step up voltage and also we may step down voltage. But I didn't ask you to say, listen, just listen. In power, just listen and look me, listen and look me. In power electronics, we may step up voltage and also we may step down voltage. Remember that in I say look me. Remember that in electric field, we used to step up electric voltage by using a transformer. Also in electric field, we used to step down voltage by using step down transformer. That's what we have learned. But we may use the field of power electronics where actually we can step up DC voltage and also we may step down DC voltage. Are we together? Are we together? You may say that why do we need power electronics? Why should you not use transformer? I say please look me. Every student look me. Listen, I'm trying to just address a very important and even a complicated concept. In electrical science, advanced electrical science, we learned about transformers. Say transformers. Say transformers. And we have two types of transformer. We have step-down transformer and step-up transformer. What the function of step-down transformer is actual to lower the voltage of alternating current or AC. So when you supply 240 volts into the step-down transformer, we may expect it to get an output voltage of 12 volts, but it's still AC. So step-down transformer conveys AC voltage into AC voltage, or step-down transformer actual lower or step down the AC voltage into AC voltage. Are we together? Also in electric science and electric engineering, we have step up transformer. Say step up transformer. Say step up transformer. So what the primary function of step up transformer is actual to step up AC voltage. To step up what? To step up what? To step up what? AC voltage. So to step is AC. The input is AC, the output is AC. In case of step up what? Transform. So lower voltage, the input is lower AC voltage, and the output is higher AC voltage. When it's come for the power electronics devices, we are not going to have to we are not using transformers to step up voltage or to step down voltage. We are going to use semiconductor devices. Right? 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 So in power electronics, we are going to have stepping down of DC voltage. So we are going to have, for the step down DC voltage, we'll be having what? A high DC, at the input we'll have a high DC voltage, it will be stepped down, and the output will be low DC voltage. Are we together? Are we together? Are we together? In power electronics also, we are going to have a step down what? Voltage. Step down DC voltage. So in case of the step down DC voltage, we say that the input is what? High DC voltage. And the output is what? Low DC voltage. So for the step up, the input is what? Low DC voltage. Output is what? High DC voltage. For the step down, the input is what? High DC voltage. And the output is what? Low DC voltage. So understand that. Because for instance, myself, when I've been learning myself, I question myself. Why do we need semiconductors just to step up DC to step up voltage and step down? So I just wanted to confuse. Why were we struggling to find another alternative? Why transformers perform well? Then I noticed the difference of the form of energy. Transformers step up and step down, so what is AC voltage. While these power electronics devices step up and step down, DC what is? Step up and step down, DC what is? Step up and step up and step down, so what is DC what is? That's what you have to remember. Is it clear? Is it clear? The first conversion is AC to AC conversion, or conversion of 40 AC into AC. So this process, it implies what? So this process, it implies what? Implies the changing of 40, the changing of frequency of electric signal. And this process, we call it cycloconversion. Cycloconversion, or we call it frequency conversion. Frequency what? Frequency conversion. Say conversion of AC into AC. Say conversion of AC into AC. So our interest here is just changing which parameter? Frequency, not the voltage, not current. Are we together? Then we say that what electric or 40 of electric signal. So we call it cycloconversion. Say cycloconversion. And also say frequency conversion. Say frequency conversion. Say frequency conversion. So you have cycloconversion, so we call it frequency conversion. Are we together? So most of these power electronics devices are used in these four processes. Most of them. And I've mentioned them because a number of them we are using in these four processes of energy conversion. Class, are we together? Are we together? Is it clear? Is it clear? So you may think that, okay, we just see, I've added a value, especially on this part, what is happening. For this part, it means the input of the system is AC. The output is AC. So, do you know what is happening for this process? Listen, for instance, this is our AC signal. And we have time. And this is voltage. So this is sinusoidal signal. Again, at this point, so we have what? We have cycloconversion. What is happening? Cycloconversion. Say cycloconversion. Say cycloconversion. Then the output is what? It is this one. Voltage. So it will be actual, the AC signal, but with a different frequency. For instance, this one, suppose that the frequency is 50 Hz. So the output signal might be having high frequency, high complete number of cycles in 1 second. So the amplitude of the voltage will not change, or the current, but for this one, you may find that maybe the output frequency is 1000 Hz. Are we together? Are we together? Yes. So we fade this, so it means that this is a low frequency AC voltage or AC signal. This is what? High frequency AC what? Signal. So this is what you have to expect. Either to change low frequency into the high frequency, or the high frequency into the low frequency. Class, are we together? Yes. Are we together? Try a level basic to learn different concepts in electronics and telecommunication engineering by using graphs, by using diagrams, by using numbers, by using formula and equation, and also by using a table of results or discussion about the results. Class, is it clear? Yes. So this is the end of lecture 1 of Introduction to Power Electronics. I would like to welcome you in lecture 2. Listen. So in lecture 2, we are going to discuss these four power electronics devices. How are we using them in conversions of power? Or what is power electronics applications of these 4 devices? In the next lecture, lecture 3, we'll be discussing about insulated gate bipolar IGBT, transistor, IGBT, and thyristors. Then we have discussed about the remaining part. So it's just a short discussion, not a detail. But that short discussion is important in order to be able to design and analyze power electronic circuits. So I would like to ask you not to attend the future lectures because they'll actually answer a number of your questions. Are we together? Yes. So this is the end of lecture 1 of power electronics devices. Firstly, I would like to take this opportunity to thank God who have given me a chance to teach you this material in the middle of actual interruptions and so forth. I would like to welcome you in the next lecture. I've enjoyed to have you, and I would like to thank you for coming and thank you for learning with me. I invite you in the next lecture. So let me appreciate my students. I always appreciate them once they understand. So now it's a time for us to appreciate you. It's a time to appreciate. 1, 2, 3. Ongereni. Imareni. Wow. So may God bless you and meet you in the next lecture. See ya.
Africa.